Okay, we're going to discuss imaginary numbers and complex numbers, and they're really not bad. Okay, so if you had the equation x squared minus 4 equals 0, okay, you would add your 4 and get x squared equals 4, and then when you would take the square root, you would get x equals 2 and x equals negative 2, okay? But if you had x squared plus 1 equals 0, or even x squared plus 4 equals 0, when you move that constant over, you get x squared equals a negative, okay? So if you were doing it in Algebra 1, we would say there's no real solution, okay? Because technically there is not a real solution. It's imaginary, okay? Because the square root of negative 1, y'all need to memorize, is just I, okay? There's a whole subset of numbers that we call the imaginary, which is just when you take the square root of a negative, you get an I, okay? So, if I were to take that I and square it, okay, that means I'm taking, if I had this definition, and I squared this to get I squared, then that means I'm also squaring the square root of negative 1, which is just going to leave me with negative 1. So you'll need to memorize that, and you'll need to memorize that I squared is equal to negative 1. Okay? Very simple. Alright? So if I have just 7i, negative 5i, I squared of 3, or even like negative I squared of 3, those are considered pure imaginary numbers. Okay? But later on we're going to talk about complex numbers. Okay? So if I give you something like this, which on your test, everything's going to be jumbled together. Okay? I'm going to tell you that now. You're going to have your real, you're going to have imaginary, they're going to be all jumbled together. So you're going to have to be able to keep them separate in your head. Okay? So if I've got the square root of negative 25, that is the same as the square root of negative 1 times the square root of 25. Okay, well we know that the square root of negative 1 is I, and we know the square root of 25 is 5. Now we're not solving, we're just simplifying, so I don't need to do that plus or minus here. Okay, the way that I'm going to write that is 5i. Okay, so it goes together. Do you have to show me this in your work? No, I'm just showing you the breakdown of why the square root of negative 25 is 5i. Okay, so then if I take the square root of negative 108, square root of 108 is not a perfect square, so I would take 108 and do my factor tree. So that's going to split into 2 and 54. 54 splits into 2, 27. 27 splits 3 and 9. 9 splits 3 and 3. So I have a pair of 2's, a pair of 3's with a 3 left over. Okay. Now I also have this negative. Okay, so we know that the square root of a negative 1 is going to be an I. So really, I've got the square root of negative 1 times the square root of 108. We know this is I. We know the square root of 108 simplifies to what? 6 square root of 3. So the way that I'm going to write that is 6i square root of 3. So your I goes before the radical. Okay? Now, if I have the square root of negative 8 times the square root of 3, you have to take your I out first. Even, bless you, even if you have the square root of negative 8 and the square root of negative 3, you have to take your I out before you multiply those. Okay? You cannot, I know it's tempting and it's the most common mistake, if you had both of these negative, well, negative times negative gives me a positive, but that is going to contradict what you start with. Okay? So here, I'm going to simplify. And that's going to turn into what? Square root of negative 8 is going to turn into what? Okay, so we know 8 can break down. 2 and 4, 2 and 2. So square root of 8 is 2 square root of 2, but we got this I. So this is really 2i square root of 2 times square root of 3. Okay? So then what am I multiplying from there? Square root of 2 and square root of 3. So my final answer should be 2i squared of 6. Now, could you have just taken out that I and done I square root of 8 times square root of 3 and gotten I squared of 24 and come down here? Yes. It'll give you the same answer. My point is you have to take the I out first. Okay? Alright, we're good with that. So real simple, you see a negative, take the I out, you're good. You continue like everything else. Okay? Now, when you are solving using square roots, okay? If I just give you this, hopefully you should recognize you take x squared and you do the inverse, you take the square root. So when I take the square root of both sides, now I'm solving it, I have to think about what I'm doing. Alright, so that's going to leave me with x equals. Now, every time you solve using square roots, you should have what? Plus or minus. Now I'm taking the square root of a negative 13. I square root of 13. 13 is prime, so that's my answer. Okay, now if I have this x squared equals negative 81, I'm going to take the square root of both sides. So x is equal to plus or minus 9i. You're good with that? Alright, solve the next example. Okay, so you should have added 7. 3x squared is equal to, divide by 3, and x squared is equal to. So when you take the square root, x is equal to. Very good. Okay, we have any questions there? All right. Now this right here, you are going to have to memorize. Okay? Simplifying your powers of I. Okay, we know that I is the square root of negative 1. Okay? So if you think about I to the 0 power, anything to the 0 power is 1. Whether it's imaginary or real, okay? I is just, I to the first is just I. I squared, we talked about earlier, is a negative 1. Now, if I had I to the third power, I could break that down and split it into I squared times I, right? Because that is I cubed. So, if we know I squared is a negative 1, I to the third power is just going to be negative I. Okay, so that pattern is what we're going to have to memorize. What we're doing, if I give you I to any super high exponent, what you can do is divide that exponent by 4 and look at your remainder. Okay, your remainder is what your new exponent is going to be, and then if you've memorized this, 1i, negative 1, negative I, then it should be very quick to do. Okay. Now this, if you recognize the pattern, you have a 1 and an I, and then from there you just negate it. Okay, so it's really not hard to memorize. if you are visual and you just have your 1i, -1, -i, and then do your 0, 1, 2, 3. Okay? That's how I did it when I learned it. So if I am asking you to simplify I to the 27th power, I'm going to take 27 and I'm dividing it by 4 because I have a pattern of 4. Okay, so 4 goes into 27 how many times? 6, and that's going to give me 24. So 27 minus 24 is going to leave me with a remainder of 3. That's my remainder. So really, I've got I to the 3rd. Okay, well, I to the 3rd is what? -I. Okay, there's a way to break that down because of the way that we did this. I to the 3rd, we broke it down, so if you really wanted to break that down so many times, you'd end up getting -I. This is the shortcut you just need to memorize. Okay, so then what did you get when you divided it by 4? So you have a remainder of 0. So I to the 0 is? Okay. So then 78, we divide by 4. 4 can go into 7. So I have a remainder of 2. So I squared is? Y'all good with that? Okay, so that dealt with your pure imaginary numbers. Now we're going to talk about what complex numbers are. Okay, so your standard form is a plus bi, and all that means is you've got a real part, which is your a, and you've got your imaginary part, which is your bi. Real always comes before imaginary, whether the real is positive or negative. Okay, so when you are dealing with complex numbers, it's almost like I is like an x. Okay, technically it's representing that it's imaginary, but when you're adding and subtracting your complex numbers, you're going to treat it like it would be a variable. You can only combine an imaginary with an imaginary and a real with a real. Okay. So if I have 8 minus I plus 5 plus 4i, because I'm just adding them, this is like when you add and subtract polynomials. You drop your parentheses, so I would have 8 minus I, and then I'm going to add what's in the second set, 5 plus 4i. Okay, then I'm going to combine like terms. So 8 plus 5 is going to give me 13. -I plus 4i is going to be plus 3i. It's in standard form, so 13 plus 3i is my answer. Okay, now if I have 7 minus 9i minus 3 minus 5i, when I subtract, I've got to be careful with everything that comes after that subtraction. So the beginning, I just drop 7 minus 9i, but what am I going to have to do with the 3 and the -5i? I'm going to change the signs because really I'm distributing that -1. If you really want to think about what that subtraction is telling me. Okay, so here I'm changing the signs and it's going to be a -3 and a plus 5i. So then 7 minus 3, -9i plus 5i. Okay, now if I have something like 10 minus 3 plus 7i in parentheses plus 4i, what am I going to do there? I'm just distributing this negative. I'm not distributing that 10. So I drop the 10, and it's going to become -3 minus 7i, then plus 4i gets dropped. Okay, combine like terms, 10 minus 3. -7i plus 4i Alright, now when you're multiplying, this is where your I squared equaling negative 1 is going to come into play. Okay? And check to pull out the i's first. Okay? So if I've got 7i times negative 9i, I'm going to multiply 7 and negative 9, and that's going to give me, and then I times I squared. But I squared is really negative 1. So negative 63 times negative 1 is going to be a positive 63. Okay, so having the square root of negative 5 times the square root of negative 10, this is where we're going to pull out those i's. So I've got I square root of 5 times I square root of 10. So when I multiply I times I get I squared, square root of 50. I've got to simplify that. Okay, I know that I squared is a negative 1. And then 50 breaks down, and when I simplify it, 50 is what? 5 square root of 2. So my final answer should be you good with that? Alright, so the square root of negative 6 times the square root of negative 12. I'm going to take square root of negative 6, and that becomes I square root of 6. For your square root of negative 12, it's up to you if all you want to do is pull out an I and then multiply 6 or 12, or if you want to simplify first. I would simplify first. Okay, so the square root of negative 12 simplifies to what? 2I square root of 3. Bless you. So then when I multiply I times 2I, that's going to give me Now I can't leave it like that. I'm going to have to simplify again. Okay, so I squared is a negative 1. And then square root of 18 is going to simplify to what? 3 square root of 2. Alright, so I'm going to multiply everything here. So 2 times negative 1 times 3, and that's going to give me square root of Alright, now the next example, what am I going to do? Distribute 4i times negative 6 and 4i times I. So negative 24i plus 4i squared. Okay. This 4i squared is 4 times negative 1. So negative 24i minus 4. If y'all haven't caught on, all you're doing is changing the sign of that term. Okay? All you're doing is multiplying by negative 1. So all that does is change the sign. Okay? So negative 24i minus 4. What do I need to do with that? Standard form. I need to have negative 4 minus 24i. We good with that? Any questions? Okay. Now we're going to talk about complex conjugates. We've done conjugates with radicals. So the same concept applies, but with imaginary. Okay? So if you recognize that it's a conjugate, then what do you do? Well, if I'm already giving you the conjugate, so if I had 3 plus square root of 2 times 3 minus square root of 2. So that would be 9 minus 2, right? You should be able to recognize it's a conjugate, so you just multiply 3 and 3, and you multiply this. And there's always a minus. and that would give you a whole number, okay? Same concept when you recognize that it's a conjugate with imaginary. But if it's not, what do you have to do here? FOIL it, okay? So what is happening is not y'all necessarily, but people get used to the conjugate, and when they see this, they're just 9 times -4, and then -2i and 7i. You have to understand you're foiling this, but this you don't have to foil. You should not have to foil, okay? So, if I work this example, I've got 9 times -4, which is 9 times 7i. -2i times -4, and then -2i times 7i. Alright, I need to clean it up. So I've got a -36, 63i plus 8i is going to give me 71i. -14i squared turns into plus 14. And then I need to do the -36 plus 14, and that gives me -22 plus 71i. It's in standard form. That's my answer. Okay? Now, 2 plus 4i, 2 minus 4i. I'm telling you it's a conjugate. I shouldn't have to FOIL that. So I'm going to take 2 times 2, and that gives me 4. 4i times -4i is -16i squared. Okay, well, -16i squared is plus 16, which is 20. Now, I do not want you skipping out on this I squared part. Yes, I know you should be able to look at that, say it in your head, -16i squared, that's a positive 16. I know how your brains work, but you've got to put it on paper, okay? So why did we bring up conjugates? You cannot have a radical in the denominator, right? Okay, well, what is I? The square root of -1. So if you can't have a radical in the denominator, you cannot have I in the denominator. Okay? So, same steps apply. If I have 2 parts being added or subtracted in the denominator, I'm going to use the conjugate. Okay? I've got to do whatever I can to get rid of this I. So, I'm going to multiply by what? Okay, my numerator. I got to FOIL it because they're 2 completely different things. So I've got 7 plus 28i plus 5i plus 20i squared. Again, don't skip out on that I squared. Now my denominator becomes what? 1 minus 16i squared. Okay? I clean up my numerator. Now, here's the deal. If you wrote this and you want to just scratch it out and you know it becomes a -20, I'm okay with that as long as I can see that you started with 20i squared. Okay? If you want to do all the separate parts, then fantastic. But if you want to do that, that's how I personally work it out, so I'm okay with that. Okay, so then I know 7 minus 20 is, and then 28i plus 5i. Alright, that -16i squared turns into plus 16. 1 plus 16 is 17. Once you get to this part, you got to check, can 13, 33, or 17 be simplified? No. So that is my answer. Okay, so 5 plus 2i over 3 minus 2i, what am I going to multiply by? 3 plus 2i. So that's going to give me 15 plus 10i plus 6i plus 4i squared, all over 9 minus 4i squared. Okay, that 4i squared turns into negative 4. 15 minus 4 is 11. 10i plus 6i. Alright, that 9 minus 4i squared turns into plus 4. 9 plus 4 is? Can that simplify? Nope. Okay, y'all good with that? Alright, what about 2 plus I over 5i? What am I going to do there? Am I doing I or 5i? You know what that sounds like? The little seagulls. I? Oh gosh, I'm recording. Okay. Alright, if I had 2 plus square root of 3 over 5 square root of 2, what would you do? I would just multiply by the square root of 2 because I don't care about that 5. I'm going to multiply it. So if you have 5i, I only need to multiply by the I. So that's going to give me over, so 5i squared. So the I squared turns into negative 1. The 5i squared turns into negative 5. So really, this is negative 1 plus 2i in standard form for my numerator and negative 5 in my denominator. If you wrote it as 2i minus 1 over negative 5 for this one step, that's okay. Alright, because this isn't our final answer. Why is this not our final answer? That negative. So my final answer is, okay, make sure you change every sign, not just the 1 and the 5. Okay, 8i over 1 plus 3i. So that's going to give me 8i minus over that negative 24i squared turns into, and that negative 9i squared turns into plus 9. So what's my next answer? So then I got to simplify it. 24, 8, and 10 can all be divided by 2. So that gives me are good with that? Okay. All right. What about when I take the absolute value of a complex number? Okay. There is a thing called a complex plane. So we know our xy coordinates, but there are planes where you've got your real and imaginary. Okay, so what you're used to in x-axis would be your real axis, and what is typically a y-axis would be your imaginary. Okay, we don't graph it. That is something that you could do, but it's really like graphing an xy. Okay. The reason I'm showing you this is because what is absolute value? If I were to take that, yeah, how far it is away from 0. Okay. So what you're really doing is seeing how far away it is from the origin. Okay. There's a whole lot of background behind it, but all you have to do is memorize that. Okay, when you take the absolute value of a complex number, you're just taking the square root of a squared plus b squared, because say my point is right here. Well, how far away from it is how far is it away from the origin? That would be the distance formula. Okay? Y'all remember that from geometry? Maybe? Yes. So x2 minus x1 squared plus y2 minus y1 squared. All under the radical, right? Okay. Well, you're seeing how far away from it is. I can't say that sentence. Seeing the distance between that and 0. So you don't need that minus x2 minus y2 in your formula. You really just need your a squared plus b squared. Okay? Why are we not even thinking about this I? Because it's all going to end up with a 1. And I is going to end up with a 1. So as long as you recognize a squared plus b squared, hold on. So if I'm taking the absolute value of negative 4 plus 3i, that negative 4 is my a, that 3 is my b. Okay? So I'm going to take the square root of negative 4 squared plus 3 squared. So that's the square root of 16 plus 9, square root of 25, which is 5. I do not need a plus or minus here. Alright? Now what about the absolute value of negative 3i? What happened to my a? It's 0. This is really 0 minus 3i. So when I do the absolute value, do I need to do the 0 squared? No. I'm just taking negative 3 and squaring it. So it's the square root of 9, which is 3. I do not want you jumping from this first part to the end. Okay? Show me enough to where I find your process in your brain. Okay? Alright, absolute value of 3 minus 7i. Square root of plus negative 7 squared. So square root of plus which is the square root of 58. Okay, square root of 58, can that simplify? Two and 29. 29. Can that simplify? So even though it looks like a 58 could be simplified, when you get here, they're both left over. You can't find pairs. Square root of 58 is all that I put for my answer. Okay? Y'all good with that? Okay. You're going to have a quiz over this. So make sure when you're practicing your worksheet, you ask me questions if you have any. Okay? It will be next class.